Fucking drop.
I might.
Over here, like,
Every time I'm voicing his life.
Like this.
Yeah. That's who they're really.
I'm not, dude, I'm part of this life.
Title.
Okay. So now we have same number of members, right?
Hold on.
Instead of applying our load vertically, we're going to apply our load horizontally. Okay? With 400 pounds, our truss has a depth of 5 feet, and then it has varying widths between point B. 8 feet between B and A, 6 feet between B and C.
There's 400 up there.
I drew it opposite, so it's like.
So you gotta flip it.
Yeah, I didn't care. I got this shit.
So, how do we determine equilibrium for our truss?
So if you take.
I have no clue.
I can, this is just like
did
a
100,
beam
you know.
where if you
Well,
did,
not for this one.
I mean, the equation I was using would be R times 14, then
So now,
400 times 6. You get the result of that divided by 14, and then that's your R1, then minus that off 400 pounds, and that's your R2.
No, it's not a point where it's going down.
It's right there. It's 8 feet. I bet if I did it that way, I could.
Say that again.
So just like on those,
But the load's in the x-axis now, it's going side to side, it's not pointing.
Oh.
Right.
it's a point. Oh, okay, so it's not going down.
What
Okay.
distance is our load away?
Okay, I see what you're saying. But on the first one, we could have
We
done.
can move it this way. Yeah, over here, we can move it in this direction, and then we're interested in
We
those
went through
dimensions.
like all those
It's like
crazy
sitting
symbols,
on-
all that. I was like, we should just do that equation in the book. and,
Yep,
there's
yep.
You know,
walls there.
that's right. Okay.
So we have.
Wow, I have no idea.
Am I trying to write these three?
Never got that one.
Yeah, draw your little thing here.
So should we look at a moment to start? Because I think it would be fairly difficult to resolve the X components of these reactions and the Y components with our given loading situation, right? Okay, do you want to look at about A or do you want to look about C?
let's stick with A.
Stick with A, okay? So our moment about A needs to equal 0. What do we have?
Absolutely no.
Is this reacting?
Yes. It's 0.
Is it causing rotation?
No.
It's not causing rotation. Is this reacting?
Yeah,
Is it causing rotation?
yeah.
Is it causing clockwise rotation?
Clockwise, yeah.
Okay.
Still doesn't get me anywhere.
How far away is it?
No idea.
8 feet. Yeah.
Careful.
I don't know.
5 feet.
How's it interacting? It's 5 feet away, right?
Either way.
We want to move it. We want to move it back here. This distance is 5 feet. Okay. These guys, when we're acting vertically, we can drop them down to our bottom chord. Okay. If we're operating in the X direction, we have to look at how far we are away in the Y direction.
It
Okay.
still doesn't tell you how far you are from the actual moment, though, right?
Sure. Sure it does.
You're telling me it's 5 feet from A to B.
Yeah.
In the height, yes, height, 5 feet up,
On the
height,
x-axis.
on the y-axis.
I can move my
Y.
400-pound force over here, can't I?
Sure.
What's this distance?
Yeah, I get that.
5 feet?
We're not figuring from A to B right now.
I understand that as well. Alright, whatever.
We'll see, like on that one, you move.
Does it, Marshall? Did it answer your question or it didn't answer your question?
Well, no, because like it doesn't it matter. Like, doesn't it matter where B is force wise? Because like B's force, what was the force? 400 pounds.
400 pounds.
400 pounds is gonna be more significant where it is at 8 feet away, whether it is compared to being just directly horizontal above it.
I agree with you. Keep in
In
mind,
regards to, I'm talking about
Yep,
in regards to.
yep, but keep in mind, if we have a 400-pound force here,
Mhm.
and think about when it exerts force on the truss, where is it going to exert that force? It's not going to exert the force here, right? It's going to exert the force once it reaches there.
Joint.
Okay.
But we're only, keep in mind that in calculating a moment, we're only interested in in a linear foot, okay? In the
Okay.
same plane. Does that help?
Yeah.
Okay. So yeah, just keep in mind, you can move these forces as long as you're not changing the line of action, as long as you aren't changing the sense, you can move them however you want for purposes of calculation. Okay? What about our reaction at C? What is our reaction at C doing?
Counterclockwise.
It's counterclockwise, right? It's trying to rotate in this direction from A. How far away is it? 14 feet away. So RC equals 1.6.
What is
It's
that?
not 1.6.
400 times 5, what is it, 14?
Yep.
That's
200, 160, something like
like
that.
141.
How much?
142. 143. you call it.
Okay.
Yeah.
At this point, do we know enough information to be able to solve for f of x and f of y? We don't, right? Because we don't know how this load is getting transmitted into the y direction through the truss.
So can't, for right there, just hear me for a second. Once RA be 257.
I don't know that we can determine that yet.
Because we're on the other
Because
axis.
this isn't acting in the y direction,
Okay.
right?
I was just, that's what I'm trying to rule out.
Yep.
My brain's gonna snap back.
If you had 400 pounds,
Down, then I
if you had
can-
400 pounds this way,
Yeah.
then you could say 257. Okay?
So that's the.
But, no,
So
go
what we
ahead.
just solved for is basically the pounds that's holding up our RC, right?
Yep, it's the resistance that you need
Okay.
in RC to prevent your 400-pound force from kicking your truss out at reaction A.
Okay.
Okay? So we can't solve these equilibrium conditions yet, but if we chopped our truss here, could we determine what's going on?
I think we got as much as we started with last time. Don't we?
Yes.
We don't know the angle.
We don't? Can we figure it out though?
We could figure it out.
Yeah.
Depends if you know figuring it out. If you don't.
Well, don't.
Now
we can update things.
Which will give us the
5
length.
feet times 5 feet squared plus 6 feet squared equals hypotenuse.
How does that give you?
And then you can just
Yeah, so it's like if you know truth that.
you don't even need to get the hypotenuse line.
No, because we
You already
already,
know 2 lines.
yeah. We have RC, which is
So what is, what does angle ACB equal? Okay, so that,
Eight what?
what does this angle equal?
60 equals 6.
Why do you say that?
Well, we know 5, so if you take the
5, 6,
sine,
7.
hold on,
So you want to say,
5 squared, 6 squared equals
Wasn't that a 2 for
something.
what do you, is sine, if you know the length across, that's sine, right, to find the angle?
It's 40. I didn't do the
opposite over hypotenuse. Do you know the hypotenuse?
So we can figure that out.
No, we know
right?
the adjacent.
You know the opposite
over
and you know the adjacent, right? So we want tangent of angle ACB equals
39.8. 40.
5 feet divided by 6 feet.
So what is tangent mean again?
It's really cheesy how I learned it when I was in middle school was if you bump your toe, you SOHCAHTOA.
Huh?
Sine, you SOHCAHTOA. If you stub your toe.
Sine is opposite over
Sine
hypotenuse.
equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. SOHCAHTOA. I know it's cheesy, but man, it got me through trigonometry. So
Some old hippie caught another hippie tripping on axle.
that would also be a way to do it. And
That's what I learned in math here.
Yeah.
That is true.
that is true.
Yes.
That's how she said it.
Interesting. It's another way to teach it, I guess. Okay, so what does our angle ACB end up being?
Been over a year.
I think it's at 40.
40 degrees?
Yeah, 39.8.
So I'm still.
Close enough, we'll call it 40 degrees.
Tangent.
Okay, so we know this angle
You have to do it inverse.
is 40 degrees.
Oh, because you're trying to.
Okay,
Tan.
what can we do with BC?
You don't have number?
How do you know when you use a freaking?
What do we do with members that are running in both the X and Y direction?
How did we get that?
40 degrees. How do you punch that into the calculator?
It's inverse tangent.
Inverse tangent?
Yep,
So how do you know to use inverse?
Because you come down parentheses.
You're solving for an angle, you have to.
well, yeah, whenever you're solving for an angle, you just use the inverse of the tangent.
I'm still trying to get the angle.
It'd be the same as, if you want to look at it from an algebraic perspective, Rush, what you're doing is you're dividing by tangent on both sides. Okay?
Hold on one. I got you. I finally got it.
And that just becomes that inverse. Keep in mind too, if you're punching it in on your calculator, you got to be in degrees to get it to spit back out in degrees, right? If you're putting it in radians, it's going to spit out a number between 0 and 7.28. Okay, and it's going to tell you that's going to give you how far you're traveling on the circumference of the circle if you're in radians. Okay. So
it's 40.
yeah,
Okay.
what do we want to do with BC?
Find the x and the y.
We want to resolve it into its x and y components, right? Okay. So BCX and we have BCY. So what is the sum of our forces in the x direction?
400.
Careful. Remember, we've chopped our truss here. We're ignoring everything on this side,
Zero.
okay? We need it to equal 0, but what's acting in the x direction?
Our,
BCAX plus
or
AC
AC,
equals 0.
Okay?
so how do you, BC.
What about our forces in the y direction?
RC and BCY.
So, F, Y.
Okay? What do we know?
We know RC is 143 pounds. So
BCY should be
needs to
negative.
Negative 143.
Okay.
Can we use this now to determine anything here? We can't?
Yeah, 'cause we know the angle.
I don't really know.
50 degrees.
Yeah, because that other angle's got to be 50, because that's the right.
degrees.
Cosine of 40 is equal to 143 over. You use cosine to find the magnitude of the RCBC.
Is cosine what you would use here? Where's your hypotenuse located?
It's the line of RCBC.
This would be your hypotenuse, right?
Yep.
Yeah.
So what would we need to use?
Why? Oh, because we were trying to, okay, I
Do you know the magnitude of
yeah, yeah, yeah.
member BC?
No.
We don't, but we know the magnitude of BCY, correct?
Yeah.
Okay?
The cosine of 50.
So we 143, 10, 143.
Do you want to do? What's that? What's your question, Kurt?
Sorry, never mind. Are you trying to solve for BCX?
We have to solve for BCX first.
Okay.
Oh, okay, so,
Once you solve for BCX, then you know AC. Now, Kurt, what Kurt is proposing, are you trying to solve BC?
Yeah.
Okay,
Can you do that?
yes. We could do that as well.
because ain't that the ultimate what we're trying to figure out?
Yeah.
Yes, but we also need AC, right?
Okay.
So,
So yeah.
we need to do both steps.
Oh, I got you.
You do.
Ultimately, the order that you do them doesn't matter, right? You don't have to determine what BCX is first to determine BC. Sorry, Kurt, I didn't see
Yeah.
where you were going with that.
So what are we talking about? What are we
All this.
So if you're using tangent, what would be the
We're going
opposite?
BCX.
You need everything, right?
What are we doing right now?
You tell me, John, what are we doing right now?
We're doing BCX.
Lost in the damn sauce.
BCX. Okay.
You want to determine BCX? Okay, so
But do you
Terry,
have the
how do you want
opposite?
to set it up?
Would it be 143 over?
Well, you don't know the adjacent.
So you want to do 143 over BCX?
Yeah.
Which angle do you need to use then? 40 degrees or 50 degrees? 40 degrees. Okay? Does everybody follow how Terry got there?
Oh yeah.
Remember, tangent is opposite over adjacent, okay? So Terry wanted to put our known value in the numerator and divide it by the denominator.
Why you guys
So
that weird?
the opposite over the adjacent is 40 degrees, okay?
So tangent 40 divided by 143. Is that what I'm?
So BC sub x will be, be 143 pounds divided by tangent of 40 degrees, okay?
170 pounds.
Okay? Yeah. So what does the force in member AC equal?
Negative 170.
Okay? And what does BC equal?
It'd still be 143.
Careful.
No, oh.
Careful, careful, careful.
140.
We have a Y component and an X component, right? What do we want to use?
So it'd be
We could use trig, or John, what could we use?
80 seconds.
We could use Pythagorean theorem, right? How much did you say?
22.
322?
222.
222, sorry. Okay, so we know a BC.
How? Never mind.
What's the question?
How do you work my calculator?
That we'd have to spend some time
You
offline
gotta
looking
do it
at.
first, you gotta do 100.
I'm not familiar with your particular model of calculator off the top of my head.
It's not really fun.
Marking that down in my review.
You have to let me know your particular calculator model type before the beginning of the semester then.
Or you just make it a buy thing you have to buy.
So, right, to force everyone to use a TI 36?
Yeah.
That's what I use. So, we know AC, right? We know BC. We would still need to analyze it we'd either have to do here or we'd have to do here because we don't have as easy of geometry this time, right? Okay?
Some numbers are
Oh, yeah. Yes, sir.
Where did we have AC? AC is 100.
I passed.
Now, one point of note, what does this mean? When we came up with AC is minus 170.
I mean, it's rotating.
What does that tell us about our sense?
Yeah.
My assumption was incorrect, right? I assumed our force was going to be applied this way. Why would it be getting applied this way as the joints are? What are we doing to this bottom chord in our loading condition?
Compressing.
Here we're actually compressing it, right?
Yeah.
As we're pushing this way, this member is going to push down. It's going to try and push down on this member. That's going to push in on C. Okay? So my assumption on the sense of that force was incorrect, and AC is actually going to be going in that route. Okay?
Good luck to the online students.
It's 11:22. In the interest of Mr. Larrabee, we'll break camp for the day. We'll finish up ABC on Thursday. How do you feel about these problems? If I give you a problem similar to this, will you be able to solve it, or do we need more examples? Need more examples?
Yeah.
That's fine.
We're gonna have to go to a
Teacher
math
homework
meeting,
on this?
honestly.
Okay.
It's been like over a year and we didn't do a lot.
Can you show me real quick?